So you think you have a pretty good handle on climate change, right? Greenhouse gases go up, the planet gets warmer. Seems simple enough. But what if I told you that's only half the story? What if there's a massive, hidden variable in the whole equation that we barely even understand? Today, we're going to dive into a really crucial paper by climate scientist James Hansen that pulls back the curtain on a planetary scale gamble we've been taking without even knowing it. All right, to really get this, let's start with the basics. You know, the stuff we all learned back in school. I'm talking about the greenhouse effect. It's basically Earth's natural, life-sustaining warming blanket. And trust me, without it, our planet would just be a frozen rock in space. So here's the quick and dirty on how it works. The sun sends down this high-energy, shortwave radiation. It zips through the atmosphere, warms up the ground. Then the Earth sends that energy back out, but now it's lower-energy, long-wave infrared heat. And the greenhouse gases in our atmosphere, they catch some of that outgoing heat, trapping it and keeping our planet, livable. It's a totally natural and absolutely essential process.
But see, that's the picture of a planet in balance. And for the last 100 years or so, we've been fundamentally changing the makeup of that atmospheric blanket. And that leads to a really big question: what if this simple, balanced picture isn't the whole story anymore? And this brings us right to the core discovery in Hansen's paper. I want you to think about the Earth's climate like a financial budget. For things to be stable, the energy coming in from the sun has to equal the energy going back out to space. But right now, our planet's energy budget is seriously out of whack.
And scientists have actually measured this discrepancy. Between 2005 and 2010, they found that the Earth had an energy imbalance of about 0.58 watts for every single square meter. Now, I know that number probably sounds tiny, right? But when you spread that over the entire surface of the planet, 24 hours a day, 7 days a week, it adds up to an absolutely enormous amount of extra energy being trapped in our system.
And look, this isn't just a theory or something from a computer model. As the paper points out, this energy imbalance is backed up by direct observations. We can actually measure the heat building up in the oceans, which is stone-cold proof that more energy is coming in than is going out. The oceans are basically soaking up all that excess heat for us.
So what's causing this? What's throwing our planet's budget out of balance? Well, it's the result of a massive planetary tug-of-war. You've got factors on one side pushing the planet to warm up, and factors on the other side pulling it to cool down. And in climate science, they have a name for these: forcings.
A climate forcing is really just any factor that messes with that energy balance we were talking about. A positive forcing, like adding more greenhouse gases, pushes the balance towards warming. A negative forcing, like a giant volcanic eruption that blocks sunlight, pushes it towards cooling. And they're both measured in those same units, watts per square meter.
Okay, now we are getting to the real heart of the matter. We know who the main players are in this big tug-of-war, but one of them is a total wild card, a hidden player whose true strength we've really struggled to measure.
If you look at this graph from the paper, you can see the first half of the story pretty clearly. That red line, that's the forcing from greenhouse gases. You can see it just climbing steadily, relentlessly up. This is the part of the climate equation we're all familiar with, the force pushing our planet's energy budget towards warming.
But check this out. At the exact same time, another one of our activities has been pulling in the complete opposite direction. This blue line represents the forcing from aerosols. These are tiny, reflective particles in the atmosphere that come from industrial pollution. Things like sulfates. They actually act like a giant sunshade for the planet, reflecting sunlight back to space and creating a surprisingly powerful cooling effect.
And here is the absolutely crucial point. The warming that we've actually measured, that's the black line right there, it isn't just from greenhouse gases. No, it's the net result of this epic battle. The warming we are actually living through is the difference between that massive warming from GHGs and the powerful counteracting cooling from these aerosols.
And this brings us to the core problem, the big, scary unknown. We know the strength of that greenhouse gas warming push very, very accurately. But as Hansen's paper states so bluntly, the cooling pull from aerosols is, and I quote, practically unmeasured. We just don't know exactly how strong that sunshade effect is, and that uncertainty has some truly profound consequences.
So this huge uncertainty has led us into what scientists have called a Faustian bargain with our own climate. We've essentially made a deal with the devil without ever fully reading the terms and conditions.
And that term, Faustian bargain, it's not me being dramatic. It actually comes from a 1990 paper by Hansen and his colleague Andrew Latzis. It just perfectly captures the dangerous deal we've accidentally struck. The very same pollution that's so harmful to human health has also been protecting us from some of the warming we've caused. So let's just play out two possible scenarios that this creates. In scenario A, let's just say that the aerosol cooling effect is relatively weak, a forcing of -1 watt per square meter. In this world, it's masking some of the warming, but the net warming we feel is still pretty high. It's a challenging situation for sure, but at least what we're seeing is close to the full scale of the problem.
But now, consider scenario B. What if that aerosol cooling effect is actually really strong? Say, -2 watts per square meter. Well, that would mean it's masking a huge amount of the underlying greenhouse warming. The warming we've observed so far would be just the tip of a much larger iceberg. And that is a far more dangerous scenario.
And this brings us to the terrifying payment clause in our Faustian bargain. If scenario B is anywhere close to the truth, then as we clean up our air to save lives from pollution, which, let's be clear, we absolutely must do, we start removing that protective aerosol sunshade. In that case, the simple, necessary act of cleaning our air could effectively double the net warming force on the planet, unleashing a wave of warming that we've been holding back all this time.
So what should you really take away from all this? The most crucial point is that our planet's climate is not some simple thermometer. It's a complex system of massive opposing forces. And because of this hidden aerosol variable, the very necessary act of cleaning our air might be the thing that accelerates climate change far faster than we expect. That's the bargain we've made, and understanding its terms is one of the most urgent tasks in all of climate science.